Hello everyone. So in this video, we will move a first step further and explore vocabulary and phrase matching using the spacy library. So we will define patterns and then we will see which phrases that matches the pattern we define. This is similar to defining a regular expression that involve parts of speech. So the first thing which we are going to see is basically rule-based matching. So what happens here is like the spacy library comes with a matcher tool that can be used to specify custom rules for phrase matching. The process to use the matcher tool is pretty straightforward. The first thing you have to do is to define the patterns that you want to match. Next, you have to add the patterns to the matcher tool. And finally, you have to apply the matcher tool to the document that you want to match your rules with. This is best explained with the help of an example. For rule-based matching, you need to perform following step. So what firstly you have to do, you have to create a matcher object. So for creating a matcher object, you can do, this is first you can import spacy, then you can spacy.load en core web sm, then from spacy.matcher import matcher and m2 matcher and you pass nlp.vocab as an argument. So now you have created the matcher object. Now next step which we are going to do is define the patterns, and that will be used to filter similar phrases. Suppose we want to find the phrases. Let me show you. Suppose we want to find the phrases quick brown fox, like this. Okay, like this. And another, you have to find a quick brown fox like this. And you can even find quick brown fox like this, and you can even find quick brown fox like this. So if you want to find the phrases this quick brown fox, so to do so we need to create the following 4 patterns. So let me just create a pattern. It's code. So in this script, you can see P1 looks for the phrase quick brown fox, that is a normal quick brown fox. P2 looks for the phrase quick dash brown dash fox. P3 looks for the quick space brown space fox. And P4 will look for the phrases quick space brown fox. The token attribute lower defines that phrase should be converted into lowercase before matching. So once the patterns are defined, we need to add them to the matcher object that we have created earlier. So to do that, so to add, we just pass m_tool dot add and qbf none p1 p2 p3 p4 that we defined earlier. So you might be wondering what is qbf. So qbf is the name of our matcher. You can give it any name, like if you want to give sbd, you can even give people's name, you can give anything, whatever you want. So it's just giving a name to your matcher. Now the next step is finally we have our matcher ready. So the next step is going to apply the matcher on a text document and see if we can get any match. So let's first create a simple document. So I've written a code which is generally I have created a sentence. So you can see the quick box frown jumps over the lazy dog, the quick brown fox eats well. And you can see clearly that I have used all the 4 varieties that we defined earlier. Now to apply the matcher to a document, the document needed to be passed as a parameter to the matcher object. The result will be all the IDs of the phrases matched in the document along with their starting and ending position in the document. So for that, let's execute a piece of code. So when you execute this piece of code, the output you get like this. So from the output, you can see that the 4 phrases have been matched. That's why you're getting all the respective values, and as we know that each position shows about the starting and the ending position of the phrase, like where we have found in that one particular phrase the respective 4 matching phrases that are there in that entire document. So if you actually want to view the result in a better way, you can iterate through each match phrase and display its string value. So for that, you can do is like execute a command. So you just need to run this code. So it's what does it takes the 2 values, like for match ID start end phrase matches, nlp.vocab.string match id span takes sentence, it goes from start to end, and you have to print the match id, string id, start and span.text. So in the following output you can see all the matched phrases along with their vocabulary IDs and the start and ending position. So this is how matchmaking is done. Now there are like more options for the rule-based matching. So if you go in the official documentation from the spacy library, it contains details of all the tokens and wildcards that can be used for phrase matching. For instance, the attribute star, the normal star which we have, let me show. So this attribute is defined to search for one or more instances of the token. So let's write a simple pattern that can identify the phrase. So I'll write that which can identify this particular phrase, because quick dash dash brown dash dash fox, or the quick, or you can even find out quick brown dash 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 fox. So first let's remove the previous matcher. So in order to remove the previous matcher so that it do not interacts with the new matcher that we will be going to define. So first we have to delete it. So in order to delete that, you have to write this particular code of m.tool.remove qbf, as we know that we have named it qbf. So when I remove it, so it will be get removed. So now the next thing we need to define our new pattern. So new pattern, I'll do this. So now you can see I have defined this new pattern. It looks something similar like this. It is just symbols like that, output star and star. I have just added because we want to have the more than one instances we are dealing with. That's why we have removed star. So the pattern P1 will match all the phrases where there are one or more punctuation in the phrase quick brown fox. So again, we define the NLP sentence. So I just define NLP sentence. So again, this is the sentence that we're going to pronounce again. So you can see that our document had two phrases, quick brown fox and quick dash brown dash 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 fox, that you should match our pattern. So let's apply our matcher to the document and see the result. So again, in order to apply the document, we will write the same piece of code that we used earlier. Just copy and paste it, and so now when you run it, you will get this phrases IDs, your phrases ID, QBF name, and you can see the 110 starting and ending positions. So you can see from the output that matcher has successfully matched the two phrases that we were looking for. The phrases were this, one phrase was this, another phrase was this. It has successfully matched the phrases. So in the last section, we saw how we can define rules that can be used to identify phrases from the document. In addition to defining rules, we can directly specify the phrases that we are looking for. This is more efficient way of phrase matching that you will also see in this video. So now in this section, we will be doing phrase matching inside a Wikipedia article on artificial intelligence. So before we see the steps to perform phrase matching, let's first pass the Wikipedia article that we will be using to perform phrase matching. So in order, we will have to just copy the piece of code. Let me just tell you. Okay. Okay, so now in this piece of code, so don't worry about the complexity of the course. It is just like it is like a scraping library, beautiful soup, which is Python web scraping library. And we just, what we did is like extract, we have went to the artificial intelligence Wikipedia page and extracted the text from there to in our Python environment like Jupyter notebook. That's why web scraping has been used, and we have parsed it, and we have used an XML parser. And in this piece of line, what it does is like it will take any piece of code which are inside the p tags. As we know in HTML, there is a p tag. So it generally looks like this. If you might have seen, if you have seen an HTML page. So this is the generally p tag. So it will fetch all the text which are enclosed in the p tag, and it will bring on the result. So basically finally the process article contains the document that we will be using for phrase matching. So the steps to perform phrase matching are quite similar to the rule mismatching. So again, first step is basically to create a phaser matcher object. So in the first step, we need to create a phaser object. So the phaser matcher object. So for that, what we do is like, again, we import spacy, load ncore web sum, and then we for spacy matcher import phrase matcher, because we are dealing with phrase matcher, and phrase matcher we pass on the NLP dot vocab. Notice in the previous section we created matcher object. Here in this case we are creating phrase matcher object, but the steps are quite similar. Now again we will create a phrase list. So in the second step, you need to create a list of phrases to match and then convert the list of spacy NLP documents as shown in the following step. So now you can see I have chosen the phrases, different phrases, and also the patterns. This is how you do it. So now again, final step is basically, so as we saw in the rule based matching, we have to again add the phrase matcher dot add, like to add your phrase list to the phrase matcher. So again, for that we have a piece of code that we need to execute. So this will just add your phrase list to the phrase matcher, and you can see we are naming it as AI. Now finally, the final rule is like applying matcher to the document. So we have scraped from using the beautiful soup. We have scraped from the Wikipedia article all the text which are enclosed in the p tag. Now what we'll do, like rule based matching, we again need to apply our phrase matcher to the document. So however, our past article is not in spacy document format. Therefore, we will convert our article into spacy document format, and we will apply our phaser matcher on this article. So in order to convert it, what we do, we need to pass it into the NLP function, the process article that we scraped from the Wikipedia article, and then phrase matcher, and then we pass the sentence, the entire sentence, after converting it into a spacy document format. So now when you run this piece of code, you will get the following output. You can see the numbers because it has matchmaking has been done accordingly. You can see. So again, if you want to see the string value of the matched phrases, you have to execute the following code, and we know that what the code is there. We have been used this code twice at times right now. So now when you execute this piece of code, you will get the output as the following, with the respective end date statement. From the output, you can see all the three phrases that we tried to search along with their start and end index and their string IDs. So this is much about phrase matching and vocabulary in NLP. I hope you like the video, and just don't worry, this is the complicated, a bit complex code, but you can just read it somewhere on Google article or regard on the spaces documentation. You will get a clear picture of it, and it's simple. So the many a times you practice this piece of code, the more efficient and more clearer, and you are more able to learn this piece of code. So yeah, thank you for the video. I hope you enjoyed.